Now, today we are going to start in chapter 2.1 that we have finished the review chapter, which is chapter 1. As always, if you whenever you feel unfamiliar with some of the topics in chapter 1, feel free to refer to it as needed, okay? And don't be surprised. It's like, but I worked so hard in chapter 1 and I got it all. How come I'm not remembering? That's not surprising. It happens, okay? And when that happens, whenever you forget something in the past, doesn't matter if it's in chapter 1 or in 5th grade, just look it up. It's no big deal. Okay, so now let's go to page 84. We are starting in chapter 2, and we're going to talk about the Cartesian coordinate system. The Cartesian coordinate system is a way that the famous mathematician René Descartes has drawn out in order to map out the ground. Okay, so what we're going to do is we'll start some point at the ground. We'll call it 0. Right here in the middle, that's 0, 0, is also called the origin. Now, the one going across horizontally is called the x-axis. Remember, this is a map on the ground, okay? You're looking down from the air, and from the airplane, looking at the ground, and we're drawing one direction as x-axis, and the other direction as y-axis, and which divide the ground into 4 parts. And we name them as quadrant 1, 2, 3, and 4 in counterclockwise direction. So now that we have done that, so remember the center where the things cross is called the origin, and it has the location of 0, 0. And that's our reference point, okay? Where do you put it? Well, you put it wherever you need, where you need it to be. Depends on what map we're talking about. And the reason we do this is so that we can then locate everything else in regard to the reference point. For example, let's say, let's look at the next page. We have, okay, next page, look at page 85 on top where we have this thing right here. Well, once we draw the x and y direction, we will draw out units for it. That is, going to in the x direction, we'll draw equal lengths and call it 1, 2, 3, 4, 5, the same way with the y direction. And then after on the other side of the lines of the origin, all the directions will be negative, okay? -1, -2, -3. Remember, minus and negative is used in the same way. Okay, so I'll call it negative. So let's so the other side is called negative 1, 2, 3, 4, 5, etc. It goes on forever. And the same as down, okay, going below the origin, the 0, 0 point is called -1, -2, -3, etc. And with this thing, what is the point of this? The point is that so that we can identify points on this on the ground in relation to the origin. For example, let's consider the point figure 4. Okay, let's consider the points 3, -1. What does that mean? That means we'll go in the start at the origin. Okay, we'll walk 3 steps and go to 3. That's 3 positive steps. So go in the positive direction 3 steps, and then we're going to turn in the y direction, which is south, and go 1 step down. That's the -1. And that is that will give us to the location 3, 1. Now let's look at the example 1, okay, which is on page, we're now on page 85, and let's look at example 1. Where we have, we'll locate some points. What point does example 1 want? Okay, example 1, let's say we need the point -2 and 4. So we have, to calculate -2 and 4, we have our system here, right? And then this is x and this is y in the positive directions. Down here and this way are the negative directions. And then, and this is the origin, that's the 0, 0 point, okay, where we start. Now first let's see, your book wants us to do -2, 4. So in the x direction, we will walk 2 steps, okay, -2. And then it says, okay, but +4. So after we get here, then we need to walk up 1, 2, 3, 4. So we have, so our final location is right here. And this point has a name called -2, 4. The name tells you how to get there. Okay, and so we will go to the left 2 steps, that's why it's negative, and then up 4 steps, that is why it's positive. So that is the location of minus 2, 4. Now please plot the rest of the points in example 1 as part of your homework. Now, next, let's go to page 86. Now we're going to plot more than just points. We're going to plot an equation. The equation, you think, well, how does that work exactly? What happens is the equation is a statement that describes the relationship between a bunch of points. That is, for example, what the relationship does this thing describe? It describes that when x is 0, what is the value of y if x is 0? Then you can calculate quickly, and that gives you y equals to minus 1. Remember, this is the x coordinate, and this is y coordinate. Okay, so if x is 0, then y is minus 1, fine. And then you can next calculate that if x is 1, then y will be 1, right? That would be 2 minus 1 is 1. So now we have 2 points, and with those 2 points, we are able to plot this thing. Okay, just like we plotted before, to plot this equation. So when x is 0, that's here, y, x is not going in x direction, you don't have to go anywhere, okay? Which way do we go? Y direction is minus 1, so we go down 1, so that is the first point, which is called 0, minus 1. And then when x is 1, we walk out here, positive direction 1 step, and then y require us to go up 1 step. So that is the next point. This point is called 1, 1. And then and these are the 2 points of our equation. Now in general, you will continue to do this with various other points. Okay, so we get different points here eventually, and then eventually we can join all the points in with some kind of a line, and that is the equation, that is called the graph of the equation. Okay, in this case, we'll join it something like this after you have done a whole bunch of other points. Okay, please do this as part of your homework. What is that? That's not even an example. Okay, that's just something your book does on page 86. But please do that yourself as well to draw this thing out and see how this works. And that is, after you draw a bunch of points, then you connect the points with a line, and that is called the graph of the equation. And what happens is that it ends up that every point on the line fits the equation. That is, even if you were to find some point here where x is, some 0.7 maybe, and you plug it in, y is still the same thing. That is, the value of y will fit into this equation. But in any case, please do the, I don't know what this is called. Is this even an example? No? Well, anyway, do this thing, okay? That is on page 86, because it gives you a solid feeling of what is graphing of an equation looks like. Okay, I know that sounds like quite a bit of work to have to draw so many points, but you only have to do this a few times. Once you get a feel for it, then you don't have to graph as many points. So please do that. Okay, please work on example. Work on page 86. I will write this down in your notes as in the video description below as doing page 86 sample. Okay, let's call this thing a sample. Anyway, so let's move on. And then remember, in studying math, the most important point is a lot like sports, like playing, say, basketball. The most important part actually is after you watch somebody else do it, that you repeat the process yourself until you get very, very good at it by repetition. So next, let's look at example 2, which is very similar to the sample we just did earlier. There's a graph. Okay, you come up with some points by making up numbers for x. Okay, these numbers are just come up with. You usually start with 0, okay, and 1, and then you might also go to minus 1, because these are relatively easy numbers to do, and then plug it in, figure out what y is. If x is minus 1, y in this case will be minus 3. right? And don't mess up because, well, try not to mess up. You probably mess up sometimes. I mess up quite often doing this type of math. But if you mess up, just find your mistake and keep going. And so anyway, so we have all these points like in example 2. And once you find the points, then you do the graph and then you are all done. And there will be quite a number of points to do, but take your time and patiently get it done and then right. So please do example 2 as part of your homework. Now, being that this is a math as a hobby class, we are not going to use any graphing utility like your book puts it. In other words, they're talking about the graphing calculator. The reason is because those things are really, well, annoying, let's just say, to me. So, I mean, I have one of these things, right? And I find them highly unpleasant. The best way to handle things is using something called the Desmos online calculator. I find that thing to be so much better and not near as necessarily painful. But if you want to, if you have a TI-84 or something like that, or any graphics calculator, and you're curious as to how this thing works, it basically is what people used back before Desmos calculator was invented. I will put Desmos link in the video description. But you can also just Google it. It comes out right away. Okay, let me. Anyway, so I'm gonna skip this part. If you want, if you want to do this, just sit down and spend some time with your calculator. If you have a graphics calculator, and do that. But that is so old-fashioned. I mean, and I didn't even like it back in my day when the calculator was first invented. I was like, ugh. It was so tedious and annoying. But it does have one benefit though. It made me appreciate the Desmos calculator so much better, where you just type it in the equation and out pops your graph. Okay, gorgeous, no pixels to look at. You know, nothing's ugly, everything's gorgeous. And I do like gorgeous, I have to say. So next, let's now move on to page 89. Okay, and then we are going to do something called the x and y intercept. Yeah, we'll start here. Page 89. The x-intercept is, what is it? It is this. Let's say you plotted an equation, like we've been doing the previous couple of examples, and then you plotted something and it looks, well, like that. Okay, your equation, after you do a bunch of points, looks something like that. Now, if that is the case, then then the place where it cuts the x-axis is called the x-intercept, right here. See, this is the x-axis, so this thing is called the x-intercept. And then similarly, this thing here, where it cuts the y-axis, is called the y-intercept. Okay, yeah. I will just write down inter. I'm worn out. That's all I want to say. But it means for the y-intercept. And how do you, there's a way to calculate the x and y-intercept, because the x-intercept is where y equals 0. So all you need to do to calculate it is set y equals 0 in your equation. Let's look at example 3 on page 89. Now in example 3, we have, well, that's not the graph for example 3, but but let's write down example 3, okay, on page 89. We have some equation that's not particularly convenient. We got fractions in it, which is okay, all right, but let's see, what are we doing here? No. So we have some equation here where we have y equals to 2/3 x, and then 4/3 plus 4/3, that's our equation. Now to find the x-intercept, notice at the x-intercept, the y value is 0, okay? It's right on the x-axis. And anything on the x-axis, the y value has to be 0. So we set this thing equal to 0, and then calculate this stuff, okay? Y 2/3 x plus 4/3. And at this point, then solve the equation. Well, actually, they don't even want you to solve the equation. Okay, fine. They just want you to click it on once you type this into the graphing calculator, or or the Desmos calculator, then you just click this point, or the graphing calculator has some way to figure out what this is. Okay, you click this point on the Desmos calculator with your mouse, and then it will outcome the coordinate of this thing, which in this case is equal to 0 and something. Okay, let's see, doesn't it say that? Sorry, that was example 3. Give me a second. Actually, example 3 only wants you to graph this thing. So please do example 3 with the Desmos calculator or graphing calculator, and let's be done. Okay, I saw the wrong thing. Now, for the x-intercept, we're doing something different, which is the thing under example 3, which is y. Here's the equation, y equals 3x minus 1. So when y is 0, when we calculate the x-intercept, then if y equals to 0, then 0 equals to 3x minus 1. We can solve for this thing. Then it will be equal to, to solve for equation, we'll move the minus 1 on this side. It becomes plus 1. Okay, whenever you move things across the equality sign, you will change the sign. That is, the negative will become positive, and the 3x stays here. And then the next step is we'll divide both sides by the same number, which is 3. The reason we do that is we want x to be by itself. Okay, so if we divide both sides by 3, then we have this equal to 1/3. And that is, what is that? That's the x value of this point right here, where yeah, okay, so this point is x value is 1/3, okay, and y value of this thing is 0. And in a similar way that we're going to calculate the y-intercept. The y-intercept means x will be 0, okay, this point, it doesn't go anywhere on x, because anything on the y-axis has x coordinate as automatically 0. So this is 0. And then what's the value of y? So we substitute in this equation here, where x is equal to 0. So y equals to 3 times 0 minus 1, and that equals to minus 1. And therefore, the y coordinate here is minus 1. So you go from 0 and goes nowhere in x direction, and go down 1 in y direction, and that is the y-intercept. And generally speaking, that's how you calculate both y and x intercepts. Next, let's go to page 90, where we consider the distance formula. And first, let's look at an example. Okay, I have a triangle drawn here where the bottom point is 1, 1. Okay, here is 1, 1. And then the next point is x is 4, y is 1. The x comes out at 4, right? Y is still 1. And then this point up here is 4, still 4 in the x coordinate. I should write down x, y. So, but the y coordinate is 5, as shown here. So we have this triangle. Now, the Pythagoras theorem, which you must always remember, which states as a squared plus b squared equal to c squared, where a and b and c is the right angle triangle. Okay, here's a, b, and c, right? That's the Pythagoras theorem. And then what we have here is that, well, the same situation applies. That is, if we are to know the distance we're trying to figure out is this point and this point. How far is this? And the way we calculate it is, first we calculate this distance, and then calculate that distance, and then use the Pythagoras theorem to calculate the third distance. So in this case, then, we know that the distance here is 4 minus 1, right? Because it's 1 here and then 4 here in the x coordinate. And so this distance is 3, is 4 minus 1 equals to 3. And this distance here from 1, it rises from y coordinate 1 to 5. So 5 minus 1 is 4. And then so this third position is the square root of 3 squared plus 4 squared by the Pythagoras theorem. Because the Pythagoras theorem, when you take the square root, would be equal to this thing, right? This is another way of saying the Pythagoras theorem. So then, so that's how we do this particular situation. In general, however, what if we have just numbers? If we have just numbers, the principle is the same. That is, we have, say, we have x1, y1 down here, right? And that in our case is 1, 1. And then we have x2, y2 and up there. And in our case, that would be the 4, 5. And how do you calculate the distance from x1, y1 all the way to x2, y2? Now, you notice that what is x1? x1 means 1, okay? Now we have a variable with a subscript on it, x1. It is then together it means one variable. That is, x1 means 1 in this case, and x2 means 4. Similarly, y1 means 1 and y2 means 5. Okay, and so when you see a subscript, that just means it's the same variable. The whole thing combines as one thing. It has the variable. Anyway, so let's say how would you calculate in general the distance from x1, y1 to x2, y2? The way you calculate it then is that we are going to do the subtraction the same as we do here. That is, we do the 4 minus 1, okay, and then so what we're going to do is the same formula here. Is we're going to do 4 minus 1, right? That equals to the distance here, okay, squared, and then we do the vertical distance, which is the b part, and then which in this case will be 5 minus 1, 5 minus 1, all right, squared, and then we take the whole thing square root following the Pythagoras theorem, and that's this, okay? So that's how we came up with it. Now in terms of variables, the same answer exists. That is, we are going to do x2 minus x1 and squared. This is x2 and that's x1, right? And then plus y2 minus y1. Oops, there's a y1 there. Let me get rid of that, y1. Okay, and so we have y2 minus y1 and squared, and take the square root of all of it, and that will give us the distance between the 2 points that we're considering. And now you might ask, how do I know which one's x2 and which one's x1? That doesn't matter. Just pick one of the points and call it x1, y1, and pick the other point, call it x2, y2, and then do the subtraction. The reason it doesn't matter which one is because your subtraction, it depends on how you do it. It might be negative, right? If you did 1 minus 4 instead, but then you're going to square it, so then it all comes out. It doesn't matter if it's positive or negative. That's the benefit of the distance formula. So then, so you just pick one, but you need to be consistent, okay? If you decide that's x2, then you start here, okay? The subtraction starts here, and then if you decide that's x2, then the subtraction start there. Just be consistent. Do not confuse yourself by mixing stuff up unnecessarily. So as long as you follow the distance formula exactly, and that will give you the right answer. Let's look at the next page. As I have said, the next page gives the distance formula, which is equal to x2 minus x1 squared plus y2 minus y1 squared, and take the square root. That's the distance. That is, in other words, the distance formula is just another way of saying the Pythagoras theorem, right? I mean, this is the Pythagoras theorem. Here's the distance formula. What's the difference? There's none. Okay, it's exactly the same thing. So having said that, let's please do example 5 as part of your homework. So for example 5, all you have to do is let x1 be minus 3, okay? x2 equal to minus 1, and then x1 is minus 3, y1 is negative 1, and then x2 is 2, and y2 is 3. And then you plug all those 4 numbers into the distance formula, and then out pops your answer. And you can leave the answer in radical form if it doesn't take the square root easily, okay? in this case, of course, this is the 3, 4, 5 triangle. So 3 squared plus 4 squared is equal to 25. And so that is the 3, 4, 5 triangle. And it's helpful to remember the 3, 4, 5 triangle because that's one of the few squares that all come out even. Okay, it's just 3, 4, 5. Okay, nice and comfortable. And so that's that. And then, so next, we're going to skip example 6. It has too many words for too easy of a problem. So let's go straight to page 93 where we consider the midpoint formula. The midpoint formula is if you have 2 points, okay, what is the middle of it? The middle of it is what you're going to do is calculate the average of the 2 values. That is, in the midterm formula it's best for you to just memorize this thing, okay? Where that is the middle happens to be the x1, here's x1, y1, there's x2, y2. The midpoint just happens to be x1 plus x2 over 2, and then y1 plus y2 over 2, because because it's the middle, which means you go halfway this way, okay, and then go halfway up. And how do you calculate the halfway? The halfway is calculated by adding the 1 plus 4, that is adding the x values, and then divided by 2. In this case, it will be 2.5. Okay, right here, that's the middle here, and then the same way here, and then use together they form the middle point of your line segment. So please simply memorize the midpoint formula. It's how often do we use it? I don't know, sometimes. But it's an easy formula to remember. Is if you add the x values and then divide by 2, and similar with a y value. So for that, please do example 7 and then example 8, which is the same thing, finding some center of the circle, which just means you find the midpoint. Okay, apply the formula by adding the coordinates and then divide by 2. And so please do 7 and 8, example 7 and 8 as part of your homework. So we have come to the end of the section. For homework, please do on page 94, problems 7, 9, 13, 15, 17, 19, 23, 25, 31, 33, 37, 39, 41, 43, 45, and 63. Now that sounds like a lot of homework, but most of them are quite short, okay? So it shouldn't take too long to do it. But if it does take time, well, you know, you got time. Let's take your time and get everything done correctly. So, when you're done, I want to talk about some of them. Now that I forgot to say earlier that you should go do your homework, and when you're finished, then come back and let's talk about them. Now, so the only one I want to talk about is problem 13, because I want to remind you how to solve equations. On problem 13, then we're supposed to solve for equations, right? Solve for y in terms of x. Sure. Let's see problem 13. We have say we have 2x equals to 5 minus 3y. What are we doing? Solve for y in terms of x. We need to see y is over here, and we want to, what that means is we need to write down y equals to something, okay? We want to plug y completely out of here. And to do that, we are going to do the equation manipulations. What we do is first, with anything, we'll keep y on this side, wherever it used to be, and then anything that isn't directly multiplied to y or divided to y, then we'll move it to the other side. And anytime you move something to the other side of the equal sign, you will change its sign. This is positive, it will become negative. If it were negative, it will become positive. So this becomes 2x minus 5. Okay, and then we have negative 3y here. And the second step we're going to do is, being that this is there's anything that's in front of y, we're going to divide it on both sides. So then we will write down the division, 3x minus 5, okay, and that divide by minus 3. We are dividing first to do division. We will divide by both sides. See, both sides are being divided, and then as a result, that is the equality rules, because equation means that these two are the same, right? Both sides are identical. So if we do the same thing to it by minus 5 on both sides, then everything still holds. So that's why if you move something to the other side of the equation, you just slap on the opposite sign that it has. That will even things out. The same when it comes to division, then then to get rid of the negative 3, you will put the negative 3 under every single thing on the other side. Okay, everything gets divided by minus 3, and that gives us what y is. Now this equation might also be written like this. Notice that your negative sign you might slap it on top, because the negative signs in fractions can be moved up, down, it doesn't matter. So then we can also write this as negative 3x minus 5 in parentheses. Okay, and that is another yeah, that's an x, in case you're wondering. And then eventually you can also write that thing as equal to y minus 3x plus 5, because 5x. Okay, and the reason is because the negative sign is the same as negative 1, and you can multiply by each thing inside, which becomes minus 3x, and then minus minus becomes a positive 5. Okay, these things are all equivalent, and you can write them any of those as your answer, and they will be acceptable. All right, so that marks the end of this section.